Environmental Science, Chapter 16, Air Pollution, Local and Regional. Air pollution is a widespread environmental problem because it occurs at many scales: indoor, locally, regionally, and globally. Regional and global air pollution is difficult to control because the polluters are often very distant from those damaged by the emissions. Each year in the United States, air pollution causes billions of dollars in damage in healthcare, crop and livestock losses, weathering of statues and buildings, and cleaning costs, even to things like clothes. We know that air quality has improved since the 1970s, and indoor air quality may be more of a threat to humans because we spend so much time inside. There are 6 so-called criteria pollutants. They include sulfur dioxide, nitrogen oxide and dioxide, ozone, lead, and carbon monoxide. Criteria pollutants have 2 main sources: the burning of fossil fuels and industrial processes. Transportation is the largest source of carbon monoxide, volatile organic compounds, and nitrogen oxides. Stationary fuel combustion is the largest source of sulfur oxides, which cause acid rain. Industrial processes besides fuel burning are the largest source of particulates, which are not listed as criterion pollutants, but still have a huge impact on pollution in the air. Fossil fuel burning is the source of many of the pollution we breathe, which is why many environmentalists would like to see renewable energy sources, such as solar or wind energy. Particulates usually classified by size, but size varies greatly. Coarse particulates usually associated with direct emissions, whereas finer particulates usually are associated with secondarily produced particles from pollution already in the air. Particulates are the single most damaging air pollutant to lungs. Particulates can also absorb toxic chemicals and therefore be a compound problem. Particulate air pollution has decreased in the last few decades in wealthier nations. Sulfur oxides are produced by burning sulfur-containing fossil fuels, especially coal. For overall human damage to humans and the environment, sulfur dioxides may be the most serious local and regional pollutants. Sulfur dioxide itself is directly toxic to living things, and sulfur dioxide is the main cause of acid rain and precipitation. Acid precipitation has pH values lower than the average of 5.6 of normal rain. Acid rain and dry acid deposition both damage the physical and biological environments in which they land on. Physical damage includes plant discoloration, corrosion of metals, dissolution of marble or mortar and other lime-containing building material. And biological damage affects both forests and lakes, such as inhibiting reproduction of fish and amphibians. This is a map of the average pH in the eastern United States. As you can see, there's a concentration downstream or downwind of the biggest coal-fired plants that exist in the Midwest. These coal-fired electricity plants have very high smokestacks. When that smoke gets removed from their state and then up into the clouds, the sulfur turns to sulfuric acid and then comes down in the rain and changes the pH. The most effective and cheapest way to reduce sulfur oxide air pollution is input reduction. Switching to low sulfur coal can reduce emissions between 30 and 90%. In addition, washing high sulfur coal prior to combustion reduces emissions effectively. A more costly way is to use scrubbers to remove sulfur dioxides after fuel combustion, which can create several problems: high cost, sludge disposal from the removal, and a high water demand for this method, which then becomes contaminated. Smog and photochemical pollutants are another major source of pollutants caused by combustion of fossil fuels. Photochemical pollution is produced when sunlight initiates chemical reactions between various nitrogen oxides and volcanic organic compounds and other components of the air. Photochemicals are secondary pollutants produced by reactions among other air pollutants when the sun's energy hits them. This is the typical concentration of nitrous oxide and ozone in Los Angeles over the course of a day. Starting around 4 a.m., you see an increase in nitric oxide and nitric dioxide. These chemicals are released into the atmosphere, and then the sun hits them, and there's a reaction that creates ozone, which is the primary component of smog. After the sun goes down, the photochemicals are also go down. Ozone, or O3, is the most abundant secondary pollutant and may be responsible for about 90% of all air pollution damage to crops. Ground level ozone forms the primary constituent of smog, as I said before. Whereas stratospheric ozone protects the Earth from ultraviolet radiation, ground level ozone can cause lots of respiratory problems to human beings, livestock, and other animals. In order to reduce ground level ozone pollution, you have to reduce nitric oxides and volatile organic compounds from exhaust of carbon burning machines. Altering the combustion process can reduce NOx's. Unfortunately, in vehicles, that practice usually minimizes one, often increases the other. Carbon monoxide is also a pollutant that comes out of the tailpipe. It's a colorless, odorless, tasteless gas which interferes with the ability of red blood cells to transport oxygen. For the most part, carbon dioxide doesn't hang around as long as the nitric oxides or the VOCs. However, if you produce enough of it in an immediate vicinity, it can cause lung irritation and pulmonary issues. Usually it's produced by the incomplete combustion of such things as fossil fuels, wood, or even tobacco products. Ways to reduce vehicle emission pollution include pre-combustion from reformulated fuels. In Maine, fuels contain 10% ethanol. That's a reformulation of fuels that help burn all of the carbon that's in the gasoline and reduce volatile organic carbon emissions. You can also have post-combustion controls, such as catalytic converters. A three-way catalytic converter has three simultaneous tasks. It reduces the amount of nitrogen oxides in the exhaust formula, creating atmospheric nitrogen and oxygen. It also reduces the amount of carbon monoxide by turning it into carbon dioxide. Oxidation of unburned hydrocarbons to carbon dioxide and water is also reduced. You can also have an alternative engine design to reduce things coming out of the tailpipe of fossil fuel burning engines. Changes in diesel engine design, for example, contribute to some tenfold decrease in emissions over the period from the late 1980s to the early 2000s. The most important of these engine technologies are advanced fuel injection systems, air intake improvements, combustion chamber modifications, and electrical engine control. Additionally, exhaust gas recirculation, or EGR, was introduced on both light and heavy diesel engines to control nitric oxide emissions. Low-emission engine design combined with increased exhaust gas aftertreatment will continue to play a role in future diesel engine design as well as gas engine design. Weather can also have an impact on air pollution, both locally and regionally. Local conditions can strongly influence the impact of air pollution, and air pollution can also affect local weather by creating so-called heat islands and providing condensation nuclei where precipitation can form around particulate. Usually within the lower atmosphere, the so-called troposphere, the air near the surface of the Earth is warmer than the air above it, largely because the atmosphere is heated from below as solar radiation warms the Earth's surface, which in turn then warms the layer of the atmosphere directly above it. An inversion is a deviation from the normal change of the atmospheric property with altitude. It almost always refers to a temperature inversion, in other words, an increase in temperature with height rather than a decrease. Under high pressure, the normal vertical temperature gradient is inverted such that the air is colder near the surface of the Earth. This can occur for when, for example, a warmer, less dense air mass moves over a cold, denser air mass. This type of inversion occurs in the vicinity of warm fronts and also in areas of oceanic upwelling, such as along the California coast in the United States. To summarize, inversions are caused by rapid radiation of ground heat, or high pressure causes upper atmosphere to heat up as pushed down on top of the dense ground air. Or you can have upwelling near a coast that would create a pressure differential. In addition, heat islands can be caused by urbanization and that change the energy balance. These concentrate or trap heat and reduce evaporation. Buildings also block wind and reduce convective cooling. This can cause more precipitation through condensation of nuclei in or around heavily populated areas. In this section, we talked about what the costs of air pollution are. We defined what the criteria of pollutants are, and we also talked about particulates. Then we talked about what the sources of air pollution are, the effects of the particulate, how the criteria of pollutants affect the planet, what is smog and photochemical pollution, and what thermal inversion is and how it affects air pollution by trapping it.